In this lesson, we are going to determine the resultant force of two forces which are perpendicular to each other. So by the end of the lesson, you should be able to determine the resultant force of two forces which are perpendicular to each other. Let's look at an example of such a question. In this example, you are told that the diagram shows an object acted upon by two forces which are acting at 90 degrees to each other, and you are required to determine the resultant force acting on the object. This is the object, these are the two forces, and you can see the angle that their lines of action make with each other is 90 degrees. How do we get the resultant force? We are going to follow a very simple method. The first one is that we are going to draw lines here. For example, I'm going to draw a line here which is parallel to this direction, and another line here which is parallel to this direction, and then I will slide this force all the way from this point to this point so that its tail is connected to the head of this other force. You remember in the previous lesson we have already said that the first step is to connect the two forces in such a way that the head of one of the forces is connected to the tail of the other, and we can do that by just sliding one of the forces from this point to this point. And therefore we are going to draw the resultant force from this tail all the way to the head of this other force, or to the last head. This is the resultant force. F is the resultant force. Alternatively, we can slide the 40 Newton force as in this diagram. So remember over here, the force that we are sliding is the 30 Newton force from this point to this point. In this case, we are going to slide now the 40 Newton force from this line all the way to this line. And then draw the resultant force from this point all the way to the last head. Either way, you realize that F has got the same magnitude and the same direction. So it does not matter whether you slide the 30 Newton force first or the 40 Newton force first. The result is the same. Now let's see how we calculate the resultant force, which is F. Now the first thing we realize is that if we have the 40 newtons here and the 30 newtons here, or even 30 newtons there, 40 newtons there, we realize that this shape is a right-angled triangle, and F is the hypotenuse of the triangle. We remember the Pythagoras theorem, which states that F squared is equal to 40 squared plus 30 squared. 40 squared is 1,600, while 30 squared is 900, and that gives me 2,500. In order to get F, I will simply get the square root of 2,500, and this gives me 50 newtons. It's just as simple as that. When you've provided two forces which make 90 degrees with each other, the first thing is to connect them head to tail, and then connect from the first tail to the last head. That arrow will represent the resultant force, and we can work its magnitude using Pythagoras theorem. Now let's draw up a summary. When you are given two forces which are perpendicular to each other, and then you are required to determine the resultant force, you proceed as follows. You complete this rectangle, slide one of the forces from this point all the way to that point, draw a line from the first tail to the last head, and you call that the resultant force. Or you can slide the second force to the head of the other force in such a way that its tail is connected to the head, and then again draw a line from the first tail to the last head, and again this is the resultant. And the resultant force is obtained using Pythagoras theorem as shown. In this case, it will give us the magnitude of 50 newtons. So remember, you just need to square this plus the square of that, and then the square root of the answer will give you the resultant force. It is just as simple as that. In the next lesson, we shall look at a situation whereby the two forces now do not make an angle of 90 degrees, but let's say an angle of 30 degrees with each other.